Today we're looking at polymers.
Polymers. Word has lost all meaning.
Plastics, latex, rubber, and our favorite polymer, slime.
Oh, yeah.
All on this episode of Science Max Experiments at Large.
Oh, greetings, Science Maximites. My name is Phil, and I think I might have overdone it with the science. I mean, what's a better use of science than creating a whole bunch of slime? Well, I did, and you know what? It's really cool. Slime. I love slime. It always makes me feel like a mad scientist, but I need a good mad scientist laugh. Yeah, it needs work. Anyway, today we're talking about polymers. Polymers like slime. But you see, polymers aren't really a substance. They're more how something is constructed. And there's all kinds of different polymers. There's slime, obviously, and rubber polymers, like rubber. And there's also hard polymers like plastic. Now, polymers are all kind of constructed the same way. Like this. This is a chain. Yeah, so imagine this is a chain of molecules, and all the molecules are the same, and they just repeat in a long line. Now, when you get a polymer like slime, all the chains are not connected or very loosely connected, which means that they can flow over each other like a slime or sort of like a liquid, and they behave like that. So that is slime. But when you get to a rubber polymer, you start to get little bonds in between the chains of polymers that work like this. You see, they still move around a little bit, but they can spread apart, and they become flexible and bouncy. Yeah, I know, a chain doesn't really bounce, but rubber polymers do. Huh? Now, when it gets to a solid polymer like plastic, there's a lot more links, and it's all kind of interconnected, and it doesn't move at all. It doesn't move. Okay, again, harder to tell with a chain, but plastic is very hard and rigid. So let's dive into the world of polymers and make some slime. Yeah, too mad, not enough scientist. I'll keep working on it. Anyway, to make slime, take your white glue and pour in an amount. It really kind of depends on how much slime you want to make. Now, you want to add about twice as much water as that. Yeah, somewhere around there. Great. Now we want to put in just a little bit of soap. Maybe there, that's good. And you want to put in your food coloring. I like green. Green seems like the right slime color to me. It's the right appropriate mad scientist kind of slime. And then you want to start mixing that up till you get the right kind of consistency. That means make sure the glue and the water are equally mixed up. Good. And now we're ready to make it an actual slime by bonding the polymers together by adding liquid starch. Very good. And you want to mix it up.
When you add the liquid starch, it starts to bond the chains of molecules together, changing it from a liquid to a slime.
It's coming along. And there you go, slime. Now, if you want clear slime and not opaque slime, you want to use clear glue and not white glue. But that's basically the recipe. So there you go, slime. Too supervillain? Yeah, okay, well, anyway, all right. Now all you need is an expert to help me max it out. Of course, my interface is hand gesture based, so I don't know if the slime. Oh, hey, there we go. Great. So you get it. Oh, of course. Sarah from Mad Science. Mad Science, they really know their slime. This is great. Okay, I got it. Close. Hey, there we go. All right. Ugh. I'm not sure bringing it through the portal is such a good idea, but at least I'll have it on the other side. Ugh. I have a pot. Why do I have a pot? I didn't have a pot when I went through the portal. Is someone somewhere missing a pot, or did it just create this pot out of nothing? Huh. Hey, Sarah!
Hi, how are you doing?
Good, Sarah from Mad Science, you're gonna help me make some slime.
Yes, I actually brought some. Oh, this isn't slime, this is a pot lid.
Hey.
Oh,
Well, at least we have a set. Doesn't answer any questions, though. And I guess we're gonna have to make some more slime.
Definitely. What kind of slime do you want to make?
What do you mean, what kind? Is there more than one kind?
Oh yeah, there are tons of different kinds of slime with lots of different ingredients and recipes.
Oh, I only know the one. Can you show me all the others?
Of course, let's go make some right now.
Okay, great.
Awesome.
Come on down to Sal's Science Shop and see me, Sal, while you shop for science. This week only, Sal's one-of-a-kind, once-a-year Polymer sale. 50 to 75% off anything made of polymers. Rubber? That's a polymer. Polystyrene. When you're eating your next meal, I recommend some polypropylene. Low-density polyethylene. High-density polyethylene. You want some polytetrafluoroethylene? We got it. We've even got polychlorotrifluoroethylene. Do they even know how good a deal this is? Because you're not gonna find that kind of deal just like every day. But hold the phone. Polymers aren't just plastics. Rayon, nylon, Teflon, you name the lawn, we got it on sale. What do we want? Polymers. When do we want them? Anytime during normal business hours. Wool, silk, even cotton. Polymers, polymers, polymers. Polymers, polymers, polymers. Word has lost all meaning. Glue, paint, umbrella fabric, oh yeah. Carpet, you bet that's on sale. Roberta, I'm running out of sale signs. Buy it and I'll put it in a plastic bag, also made of polymers. Seriously, Roberta, we can't have a sale on everything. Oh, hey, even you, even me, the proteins in our bodies, even our DNA, all polymers. So come on down to Sal's Science Shop and get a great deal on your polymers for a limited time. I mean, it'd have to be a limited time, right, Roberta? Because, I mean, I can't discount everything in the store to 75% off. How am I gonna make any money? I mean, are we still rolling? 100 different kinds of slime.
Yes, it's gonna be so much fun, but we're not gonna make 100 today.
Yeah, I know. We're just gonna do our top favorites.
Yeah, it's gonna be super great.
All right, what are we starting with?
So our first slime we're starting with today is some really cool molding slime. Now this slime, actually, if you leave it out overnight, it'll harden and you can make an imprint of whatever you like. So here, we made an imprint of our little tool there. So we're gonna look at a little bit more liquidy slime, starting with this one over here, which I believe you already know about.
This is cornstarch mud.
Exactly.
You hold this.
Sounds
I'm gonna
good.
hold this and we're gonna try pouring it. Whoa, oh,
Whoa.
so, see, it's like a liquid, but then if you do it fast, it's like a solid. All right, what's next?
Over here, we have some other really awesome types of slime. So right over here, we have some crunchy slime.
Crunchy slime?
Exactly.
Why is it crunchy?
Now it's crunchy because we've actually added a few beads inside of it to make it crunchy. So this is some really cool, awesome slime.
Here, you take half.
And you can feel the beads as you stretch it out. It's so cool.
This one is a little harder to clean.
Exactly.
I'll just do that. All right, so what's next?
So next we have some really cool glow-in-the-dark slime.
Glow-in-the-dark slime?
Yeah, it's so awesome.
Ooh, look at how much it glows. That glows a lot. That's super glowy slime. So to do the different kinds of slime, we need the polymer.
Yes.
And then the thing that sticks the polymers together.
Exactly.
So the glue is the polymer.
Glue is the polymer.
And the starch is the thing that bonds it.
Yes.
Uh-huh.
Very cool.
And then you put the thing in that makes it the kind of slime.
Yes, right before you add the bonding component, because if we keep adding stuff after it's already made, it unfortunately won't be able to take it. So we add our powder before we add our starch in this situation.
Should we go on to the next thing?
Yeah, let's move on to
More slime! Plastic is great, and plastic is everywhere. But the problem with plastic is it isn't very biodegradable. It doesn't break down in the environment. I'm still on hold. Oh, well. There you go. Back for another couple years, I guess. But here's a way that you can make bioplastic. It's fully biodegradable because it's made of natural materials.
The recipe is easy. 2 parts cornstarch, 3 parts water, a few drops of cooking oil, and some food coloring to make it whatever color you want.
Purple, science purple.
Mix it up and it turns into a paste.
Now what you'll need are 2 things. 1, an adult, and 2, a microwave.
Put it in for 30 seconds.
Clock wipe. There we go.
Then take it out and mix it some more until it cools down. Then you can pull it out and use your hands to sculpt it into a shape or take the shape of something else.
Once you put it all the way around, you can turn it into a little flower pot.
Once you've sculpted it,
You need to wait for it to dry, which will take about a day. Clock wipe.
after waiting a day,
Huh? What? It's been a day? Oh.
you have something made out of bioplastic, like this little flower pot you can use to grow a small plant.
And then when it grows big enough, you can take this biodegradable flower pot and plant it right outside in the dirt, and this pot will biodegrade and turn back into dirt. Pretty cool, right? Well, let's max it out. Biodegradable frisbee! Check it out! It's a frisbee, but it's biodegradable. So you throw it around in the park, but if you lose it, it turns back into dirt. Ha! What, not enough? Okay, clock wipe! Biodegradable lawn chair! Use it for one season and then return it to the earth afterwards. I think this is one of my best Science Max. Okay, bioplastic lawn chair, not as strong as regular lawn chair. We've learned that lesson now, so that's good to know. I mean, how would I have known if I hadn't tried it?
Sarah and I are looking at different recipes for slime.
All right, what do we got here?
So over here we have some amazing foamy slime, which has so many ingredients in it. Here, watch what happens when we start pulling it out.
Ooh, wow. So it's like,
Super stretchy and super fluffy.
here, that's great. Okay, now you gotta hold yours. You gotta hold this end. Okay, you take, and then take some more. And then we take that. And then, yeah. It gets thinner and thinner, and it becomes more and more lines of foamy slime.
Yeah. And the last kind of slime we made today is some classic flubber slime.
Ooh.
So much fun.
Now, why do you think is it flubber slime? Because is it really a slime?
It is a slime, yeah. It's super fun and it's super stretchy.
Oh, okay, I get it. Look at that, and it's sort of like a little bit like gelatin.
It is almost like gelatin.
Here, you can have some. There you go. Whoa. Ah, whoa. All right, so Sarah, now what we need to decide is how we're gonna max it out.
Right.
Like, should we just get a lot of slime?
That sounds like a really good idea, but we are gonna need something to put it in because we can't just have slime all over the floor.
Okay, you're right. So we'll get some sort of container thing.
Yeah.
And we'll see how much slime we can make, and then we'll just play with it and see what happens.
Sounds good.
And yeah, we will experiment because it's science.
Yeah.
Okay, high five. Careful high five so we don't splatter. Okay, good. Okay, let's go. This is right.
This is a rubber glove. Well, actually, it's a latex glove. What's the difference? I will get to that in a second, but I'm sure you can agree it's super stretchy. How stretchy? Let's fill a rubber glove with water and see how big it gets. So, difference between latex and rubber. Well, it all comes from a rubber tree. Well, actually, it's a fake tree. It's just to show you how it works. The sap of the rubber tree is collected just like this. There's a spigot, and then the sap goes out, and it's collected. It's the same way that the sap for maple syrup is collected. And this is natural latex. If it's dried out, it becomes natural rubber. Latex generally means the liquid form, and rubber means the solid form. But wait, then why is this a latex glove? The glove is not liquid. What's the deal? Well, generally, latex means water-based or liquid, like latex paint. But it could also mean synthetic latex. That's latex that's man-made and doesn't come from a rubber tree. So, we call rubber gloves because they used to come from rubber trees, but now they're usually made out of man-made latex. But either way, they're super stretchy. I wonder how big this is gonna get. Science! Sarah and I are maxing out polymer slime. How? Maxed out tub of slime! Whoa!
Okay, so how do you feel? Are we mixed up enough?
First, we mix up a bunch of slime in a garbage bin.
So with the polymer chemistry, the polymer is generally a liquid, right?
Yep.
And the bonding agent makes it stick together. So the more we use, the more of a solid we get.
Exactly, yeah.
So we want to split it and make it sort of halfway between a liquid and a solid, and I think we're exactly at the right stage.
It looks perfect.
Oh, yeah. Okay, so let's dump this garbage can in.
All right.
All right. Then we dump it in.
Oh, gross.
Turns out we needed more slime.
I don't think that's gonna be enough.
I think we may need some more slime.
Yeah, how much more do you think we need?
So, we added 11 more.
Ah, delicious.
Perfect.
Last one. Oh, yeah.
Then we experimented.
Oh, yeah. We have a giant tub of slime.
Because the slime is stretchy, it created amazing bubbles.
So do you think I could blow a bubble with the slime?
Well, maybe not you, but definitely
wanna
the air
try this?
compressor.
No, no, I'd have to just put it on my face. I think I've
Yeah.
already got it on my face.
Then there was only one thing left to do.
We get in the slime.
Can we do that?
We can totally do that. This is Science Max.
That's so exciting!
Going swimming in slime.
Yes!
Who's going first?
You are!
I am, obviously. All right, this is how Science Max does polymers. 3, 2, 1. Plastic is everywhere, but what can we do with it aside from recycle it? Well, we can reuse it to make cool plastic charms. But you're gonna need the right kind of plastic, and you need polystyrene. Just look for the little number 6 inside the recycle symbol.
Cut out some plastic and decorate it however you want.
There we go. Haha, check it out. The Science Max logo. Also, I've made a couple other things. I've got a chemical symbol, an atom, and this is me in some slime.
Then get an adult to help you put it in the oven or
Toaster oven.
at 350 degrees. It only takes a few seconds for the plastic to shrink to 1/3 its size.
The reason why this happens is when plastic is manufactured, it's heated and stretched out and then cooled, and it sort of freezes in that stretched out shape. And when you reheat it, it shrinks back down to the unstretched shape.
Get your adult to take it out and wait for it to cool, and you'll have yourself some small plastic designs you can use for keychains, bracelets, name tags, bookmarks, whatever you want, all using the power of polymers.
Awesome. I'm gonna make all of those. What was that again? Keychain, ornament, magnet.
Magnetic putty in 60 seconds.
This is magnetic putty.
Thank you.
This is magnetic putty.
10 take.
This is magnetic putty.
26.
This is magnetic putty.
2,635.
This is magnetic putty.
I can't count this high.
This is magnetic putty. Magnetic. Oh, it's not a magnet. It's attracted to magnets. Oh, that makes more sense. This is magnetic putty, and this is a magnet. The putty is made of polymers, which means it can flow over itself. It also has lots of iron filings in it, which is why it's attracted to magnets.
This is what happens over several minutes.
And there you go, magnetic putty.
Okay, so where were we? Oh, yeah.
3, 2, 1, yeah!
And remember, don't try this at home.
Slime!
Sarah and I enjoyed our maxed out tub of slime. So let's recap. Slime is made of polymers. Polymers come in a lot of different forms. It's all about long chains of molecules. And none are more fun to swim in than slime.
Do I have slime here?
Ooh, yeah, definitely.
Slime here! Oh, slime! Well, there you go. Science Max experiments at large. Polymers. Slime. Yeah. High fives. Yeah. Slimy high five. Yeah. Science Max! This episode of Science Max is a messy one. We're looking at solids, liquids, and gases, and things in between, like cornstarch mud. Today on Science Max, experiments at large. Behold the power of states of matter. Greetings, Science Maximites. I'm Phil McCordick. I think I overdid it with the fog machine. This is Science Max, experiments at large. Can you even see me? Let's go over here. Today we're talking about states of matter. Now there are three main states of matter. Solid, like this table, liquid, like the water in this beaker, and gas. Yes, thank you. And we're also gonna be looking at the things that kind of go in between, things that are sometimes solid, sometimes liquid, like cornstarch mud, which is very easy to make. All you need is water and cornstarch, which you can get at the grocery store. Mix it up however much you want. Just remember, 2 parts cornstarch to 1 part water. Twice as much of this than you have of that. Very easy. Mix it up and you get cornstarch mud, which sort of seems like a liquid unless you hit it. And then it becomes solid. But if I pour it, it's a liquid. Even if I hold it in my hand and I hit it really fast, it turns into a ball, and it will stay in a ball as long as I keep hitting it or squeezing it. But as soon as I stop, it turns into a liquid again. Now we're gonna max this out. We'll go through the portal and learn more about solids, liquids, and gases. Yeah, right. That's why I'm going to the Center for Skills Development and Training. And, oh no, wait, that's the code for the fog machine. Wait, stop. Stop, it seems to be stuck. Oh, never mind. I'll fix it later. Right. Hey, Judy, how are you?
Hi, Phil, how are you?
Good. Judy is going for her PhD in chemistry, right?
Yes.
Fantastic, because that means you can explain cornstarch mud to me. Now, is this a solid or is it a liquid?
Well, it kind of has properties of both. It's called a non-Newtonian fluid, so that makes it a liquid.
A liquid? Well, I mean, it pours like a liquid, but when you hit it, it's a solid. So why does it turn solid when you hit it?
So when you're pouring it, the particles are still far apart, so they can't interact with each other, and so they stay a liquid. But when you're hitting it, you're jamming the particles together, and they line up to become a solid.
Now, does it still work the same way if we have a lot more of it?
It should.
Great, because I've got this 20-kilogram bag of cornstarch, and I have 34 more of them.
Wow, that's a lot. But I think you'll need a much bigger container.
Much bigger container. Great. I got some wood over there. Why don't you go, and I'll follow you.
All right.
I'll follow you. I'm coming. Yeah, thanks, Ramona. And give me one of them fizzy drinks. Not too fizzy, just sort of medium fizzy. Thanks a lot. Hello, do you have trouble knowing what is a solid, liquid, or gas? Are you confused by Jell-O? I mean, which is it? Is it a solid or is it a liquid? Water is a liquid, but what about when it's ice? Well, you gotta know your states of matter. There are 3 main states of matter: solid, liquid, and gas. And there are 3 rules that you need to figure out which one of them is which. Does it flow? Does it fit the shape of its container? And can you squeeze it? Rule number 1, does it flow? Solid, liquid, gas. Here's a gas. Does it flow? Do the particles pour over each other and cascade down? Yeah, they do. Does a liquid flow? Yeah, it does. Does a solid? Nope. Rule number 2, what happens when you put it in a container? Does it take the shape of the container? Gases take the shape of the container. Liquids takes the shape of the container. Solids do not take the shape of their container. I know what you're thinking. You're thinking, I get the whole pouring and taking the shape of the container, but come on. Liquids and gases, they do both of those things. Well, it all comes down to rule number 3. Can you squeeze it? Now, solids, you can't really squeeze them. Liquids, you can't really squeeze them. Gases, ha-ha, bam, you can squeeze them. You see, gases compress. Liquids and solids, they don't really compress very well. The other difference between gases and liquids is gases will take the shape and the volume of the container they're put in. Liquids don't do that. So there you go. Solid, liquid, gas. And the rules. Does it flow? Does it take the shape of the container? And can you squeeze it? Now you know your states of matter. That'll be $6.50. Cash only.
So what is cornstarch mud and how does it work? Well, cornstarch mud is a non-Newtonian fluid, which means it behaves differently than you, or Newton, would expect. Here's cornstarch, and here's water. Cornstarch is made up of large, blocky molecules like this. Water is made up of much smaller, rounder molecules like this. When you put them together, it looks something like this. It all has to do with how the molecules slide past each other. When you put light pressure or slow pressure on the mud, the water molecules and cornstarch molecules have time to shift out of the way. But when you put a sudden pressure on it, the water molecules squirt out of the way, but the cornstarch molecules don't have enough time. So you get a section that's nearly all cornstarch, which acts as a solid. Cornstarch mud is a shear thickening fluid. Shear is talking about the force of things sliding around, in this case, the molecules. So when the shear force is strong, the fluid thickens. Shear thickening. So here's the plan. If Judy and I make enough cornstarch mud, could we run across it? Let's find out.
Yeah, I think mine is just the right consistency. How's yours, Judy?
I think I'm ready too. This is much harder than I thought.
Yeah, it's really hard to get it mixed at the very beginning, but mine is ready to go. Okay, here we go. First batch. You ready?
Yep.
Dump it in. Woo! Woo! I thought that would be more.
I thought so too.
It's really not filling this up very much, is it?
No.
Huh, that's a lot of cornstarch. This is great, but I think we're gonna have to go a little faster than this.
I think we need some sort of mixing device.
Yeah, I mean, we don't have to do this by hand. We can get some sort of machine to help us.
Yeah.
Right on, high five.
Oh.
We shouldn't high five when we have this stuff on our hands.
Nope.
Yeah, good call. This science is delicious. This is rock candy. It's basically crystallized sugar, and you make it by turning a solid into a liquid and then back to a solid again. Here's how you can make it at home. You need a container that you're not gonna need for a while, and some water, some sugar. You can use brown or white. I like to use brown. And an adult. Here's why you need an adult. You want to dissolve 3 cups of sugar into every cup of water. And you can't do that unless you heat the water. So get an adult, a saucepan, and heat the water up, pour the sugar in, and keep stirring until it's all dissolved. Then pour it in your container and let it cool down. Then you'll need a shish kebab skewer, which is something you can get at the grocery store. Cut it down to the right size so it fits nicely into your container. And then dunk it in your sugar and get some crystals coated around the stick. These are seed crystals, and they get the whole process started. And now you have to wait for these to dry, otherwise they'll just fall off the stick when you put it in the water. So I've got one here that has dried out. You'll also want something to keep it from falling in the top of the container, so I'm gonna use a clothespin. Put it in there and dunk it in the container like that. And now for the final step, if you want, you can add food coloring. I like to use red because it reminds me of science. And I'm gonna use the stick to actually stir that up a little bit. There we go. Now,
The dissolved sugar crystals in the water will slowly grow on the crystals that are already attached to the stick, and it will eventually grow into a rock candy pop. But it takes about a week. No, I'm just kidding. I've already got one that's standing by. Here we go. This one has been growing for about 7 days. And there you go, rock candy. Delicious science. Now, how can we make this any better? I mean, it's crystallized sugar. It doesn't get any more maxed out than that, does it? Yeah, it does. Come on. This is a giant container of sugar water, and I've been brewing a massive rock candy crystal in it for a while, but it's sort of getting a little bit too big to fit out the top of the container, so you know what? I'm just gonna put that back in there and chalk that one up to science because, well, eating a rock candy crystal that big would definitely not be good for my teeth, so yeah.
So our big experiment is to take a whole lot of cornstarch and fill a trough to see if we can run on it. But mixing it by hand was going to take forever. So Judy and I got a drill with a mixing attachment on the end.
Whoa, sorry. All right, so Judy, I'm noticing a bit of a problem here.
What is it?
Well, if I mix at the top, everything's fine, but as soon as I get it a little bit deeper, and then it gets really tough, and the whole bucket starts to spin, and the drill stops.
Yeah, I think it's because the drill's trying to mix it too fast. When we're mixing it by hand, it's slow and you can still let it stay a liquid, but now you're just making it a solid.
Right, because it's a shear thickening fluid, so if
Exactly.
you hit it really quickly with something, like the blades of this spinning really quickly in the thing, it'll suddenly turn into a solid, and it'll be really hard to mix.
Yep.
So we go slow. Going slow. Going slow. Suddenly realizing that if we go slow, we'll be here forever.
Yep.
You know what I think we need? Whoa, sorry. You know what I think we need? We need a different way to mix this.
Yep.
We need a way to mix more of it, and we need a way that it doesn't hit it with blades that suddenly go through it really quickly.
Something that can mix on a large scale, but slowly.
I have just the thing. Come with me.
All right.
The interesting thing about bubbles is they're a gas surrounded by a liquid. So get some dish soap and some water, and then be science maximites and find things around the house that you can make bubbles out of. Just about anything that has holes will do. Or I like this one. I call it the loud bubble. Or now it's time to max it out. I'm here at the Ontario Science Centre, and this is Anthony. Hey, Anthony.
Hey, how's it going?
Good. So you are amazing at bubbles.
I am. I've been practicing for a while. Let's get started.
Okay.
You're gonna make an okie dokie sign like this.
Uh-huh.
You're gonna dip it right into our bubble solution. Come on, get right in
Okay,
there,
right
right in
in.
there. Make sure you get it all. Oh, that's a little too much.
Well,
That's
then I
good.
can make two.
And then you're gonna keep that okie dokie sign. You're gonna blow very gently.
Nice.
I brought these two giant sticks here, and I don't know if you noticed, but I've got a smoke machine here.
Right.
So we'll turn that on, and then if you press that green button there, you're gonna shoot some smoke, and we're gonna try to catch that smoke in a giant bubble. You ready? Okay, and I'm gonna try to... Oh, that was so close.
great.
Did you see that one? You give it a shot. Nice! Oh, check that out! That's amazing! That was huge. Try it again. Let's see if I can get the smoke machine. Here we go. Go for it, go for it. Push right towards. Oh, check that out! You did it! Look at that! Look at that! No! Smoke, and it bounces on the floor because the floor, it doesn't have any oils like our hands do. Isn't that amazing?
That was
oh my
great.
God, that was so cool.
That was great. You know what I think we should do?
What's that?
Giant bubble, tons of smoke.
Done.
Okay, here we go.
Let's do it. You ready?
Giant bubble, tons of smoke. Go.
Awesome! Oh my God! Look at that! Amazing! Look at that! That's crazy!
Maxed out bubble. Well, there you go. Giant smoke-filled bubbles.
Awesome!
Yeah! Judy and I tried mixing the cornstarch mud using a drill with a mixer attachment, but it didn't work. We should have known better. Here's the mixer in our cornstarch mud. Usually, a mixer works by going really fast and mixing everything together. But remember that cornstarch mud is a shear thickening fluid. So, when the blades of the mixer tried to go fast through the cornstarch mud, it did what it always does, turn solid. The faster and harder you try to move it, the more solid it will become. This means the only way to mix it would be if we made the drill go very, very slow, which wouldn't speed things up at all. So with the drill another lost cause, Judy and I need the biggest thing around that could mix stuff
Come
up.
on back. Good. Little bit more. Perfect. A cement truck is a perfect thing to mix because all we have to do is get all the cornstarch up in here and it'll mix it, and it doesn't move it too fast. It goes nice and slow, so hopefully a shear thickening fluid will be fine. I'm gonna get Judy. She's driving the truck. Hey, Judy, that's perfect.
The only problem is we needed to get all of those bags of cornstarch into the hopper of the cement truck.
I didn't think it'd be this messy.
We needed to call the entire Science Max build team to help us out.
This is possibly the messiest thing I've ever done. Awesome! Woo. Hey, Judy, you wanna lift up any bags?
I'm okay, thanks.
That's okay. I'm having a lot of fun, so I can do them.
Cool.
Oh no! Oh no! Oh no! Yeah! I got most of it. All right, I think we're done. I think that's enough bags. Let's start the mixing! So, what do you think, Judy? Do you think it's gonna work?
I think so, because you're mixing at a very large volume, but at a very low speed.
Yep.
So throughout the process, it'll stay a liquid until we're ready to run across it.
That sounds exactly like the kind of science I like to see. You know what I really like is that every time I move, more cornstarch comes off. It's like I'm a human fog machine. This is liquid nitrogen. Nitrogen makes up most of the air we breathe, but if you get it really, really cold, it turns into a liquid. The fun thing is you can use it to make other things really, really cold too, like this banana. I have frozen this banana solid thanks to the liquid nitrogen, and normally a mushy banana would not be able to hammer in a nail, but, whoa, because it's frozen, I can hammer this nail into this block of wood. So that got me wondering, if I can turn a banana into a hammer using liquid nitrogen, could I turn a pumpkin into a sledgehammer? Let's find out. Pumpkin sledgehammer, take one. No, I think the answer is no. You cannot turn a pumpkin into a sledgehammer with liquid nitrogen. All you can do is make a really, really big mess. I'm gonna have to clean this up, aren't I?
Now we have a cement truck to help us do the mixing for our cornstarch mud. After making a giant mess getting the cornstarch into the cement truck, it's time to see if it worked.
Hey, Phil, how's it going?
Yeah, it looks like it's mixing pretty well. I'm really glad we're not doing this by hand, because it'd take a really long time. We've almost got it at the right consistency, but it's taken some time. But it's getting a little dark out, Judy. I don't know, do you want to quit and go home?
No.
Of course not. That's not what we do in science. Oh, here we go. Yeah!
Awesome.
All right, let's see it. Let's see if it's... I like how it comes down in little steps. And look, it's working just like it should. I hit it, and it's solid, but you can see it's pouring like a liquid. Yeah, here comes a big wave.
Wow.
Here it comes. Oh. Wow.
And it's totally filling up.
Oh yeah, filling up really fast. I think we should stop pouring very soon.
Yep, we may not have a big enough trough. Yep,
Liking it.
it's good.
Yeah. I think it's time. It's not even done pouring, but I'm gonna try it. Okay, you ready? Whoa.
Oh, and you did it!
Whoa. You can't. You have to get back onto the sides before you stop moving.
Or else it becomes a liquid.
All right, it's your turn.
Okay.
Here.
Go.
Okay, ready?
Okay.
You gotta hit your feet really fast.
All right.
Here, go. Yeah!
It works.
Because cornstarch mud is a shear thickening fluid, it means it stays a liquid until you hit it suddenly, like with your hands, or in this case, our feet. And then it turns to a solid. So as long as Judy and I keep slapping our feet down with enough force, we can walk on top of it.
One more dance.
All right.
And
let's
tell you
do
what,
it.
we'll do one more dance.
All right, let's do that.
Okay, ready?
All right.
And go. All right.
All right.
Yeah, there you go.
We've done it.
Solids, liquid, gases. Thanks very much for joining us on Science Max Experiments at Large. Woo! Science Max!
Today's Science Max is all about sound. We bend the power of sound to our will by making the loudest sound we can.
Wait a minute, a subwoofer.
Make cornstarch mud dance, glasses break, and things vibrate. It's the sounds of science. Today on Science Max Experiments at Large.
Greetings, Science Maximites, and welcome to... Can you hear me? Greetings, Science Max! You can't... hold on a second. Greetings, Science... Yeah, that's much better. Greetings, Science Maximites, and welcome to Science Max Experiments at Large. Today, we're going to be talking about sound. Sound is all around us. We use it every day, but what is it really? Sound is energy. Let's say that this is the... No, stay. Stay. Okay. That this spring is the sound of my voice. When I make noise, it travels away from me in a wave. One air molecule vibrates the next, air molecule vibrates the next, and it looks like a wave. And when there's a little bit of energy, the wave doesn't move very much. Science. But when there's a lot of energy, the wave moves a lot. Science! What do we do? What do we do to make sound louder? This is the Science Max theme song. But it's not very loud because the speaker on my phone isn't designed to make super loud noises. So what we're going to do is find ways to make the volume of that song as loud as possible. Here is one way. Take a phone playing some music and put it in a glass. Make sure the glass is empty, of course. Huh? And suddenly, it's a lot louder. Wow! Why this works is one of the things we're gonna be looking at today. So that's what we're gonna do today on Science Max Experiments at Large. We're gonna learn how to make sound louder, as loud as we can. But I'm gonna need an expert to help me. Oh, I know, Michaela from the Ontario Science Centre. She's very smart. All I need to do is go to the Ontario Science Centre and see if she's busy.
Are you okay?
Yeah, Michaela, it's good to see you.
Nice to see you too.
That was weird. I was wondering if you could give me a hand with an experiment.
Oh, I'd love to, yeah.
It's a sound experiment.
Sounds awesome.
Right on. Okay, we'll take the portal. We'll go back to Science Max headquarters.
Oh, you took the portal? Cool.
Haven't you taken the portal before?
No, don't you remember? It wasn't working last time.
Oh, well, it's
Is it working?
fixed this time. Yeah, no, it'll be great. Trust me. Here we go.
Phil, is everything okay?
Usually when I come through the portal, I land on something or something falls on me or...
Not today. It's your lucky day.
I guess so.
Safe landing.
Safe landing. High five. All right, so let's get started.
Okay, go.
This is the experiment I want to max out today, Michaela. I know. Pretty impressive, right? No, hold on.
Okay.
So I take my phone and I play some music on my phone and it's louder, right?
Check it out. Phil, you've just made yourself a resonance chamber.
A resonance chamber.
A
Very
resonance
nice.
chamber is what we say when we're trying to describe how the sound is amplified. So if the sound's coming in from one direction, it's bouncing around, not really losing energy. So when more sound comes in, that's amplified. We hear it a lot louder.
That's cool. So that's what I want to do. Hold on, let me turn this up. That's what I want to do today. I want to max out as much sound as we can get out of the Science Max theme song, which
I'm
is
so excited.
totally awesome. So what else can we do to do that?
Well, there's a couple avenues I'm thinking. Do you want to try something with electricity or without electricity?
That's because with electricity, we're talking speaker systems and
Yeah.
Right. So
We
why
can
don't we
get into
do no electricity for now, and then
All
we
right.
can jump to electricity when we feel we've exhausted everything that's non-electric.
Cool. So I was thinking we could try to make a megaphone because if we have a lot of sound, we could, funnel it in one direction and then it would be louder.
Okay.
What do
Yeah.
you
So
think?
the megaphone's pretty easy to make, right? We could just use. In fact, we could use this piece of paper, right?
Yeah, let's try it. What do you think?
I think it's very megaphony. Science taping it up. Okay, ready? Okay, turn it on. Play it. And doesn't sound, but what if I do this?
Hey, there it is. Right on.
Oh,
That song.
yeah? You hear it?
Yeah. Oh, I hear it.
Okay. So that worked pretty well. So,
Yeah, it works. Works, Phil.
okay, so this is pretty easy, right?
Yeah.
Megaphone?
Oh, yeah.
So why don't we max this out? Why don't we make a giant megaphone and see if it makes a big difference?
I think it will. Let's do it.
Sounds good. Let's get started. All sound is vibration, but it's really hard to learn about that vibration if you can't see it. I mean, sound is invisible, right? Well, here's a way that you can make sound visible. All you need is some plastic wrap and salt and a bowl, just a regular bowl, and an elastic like this. So what you do is you take the plastic wrap and cut off a piece just large enough to fit over the bowl, and then use the elastic to wrap around the bowl to keep the plastic tight. Pour some salt on the bowl, and then watch this. Hello, vibrating salt. The plastic wrap is stretched tight over the bowl, making it like a drum. A drum that's very sensitive to sound vibrations. Your ear works the same way. That's why we call it an ear drum. The vibrations from my voice make the plastic wrap vibrate, and that makes the salt dance. But there's more. Let's max this out. This is a Chladni plate, and what it is just a piece of metal on a platform that vibrates up and down to a frequency which I can program with this dial here. And when the sound waves vibrate the plate, they can interact in ways that make the sand form interesting patterns. Take a look. The sounds I'm generating vibrate the plate, make it move like a wave. But when the vibrations reach the edge of the plate, they bounce back and interact with the other waves going the other way. The way these waves interact at different notes is what causes the sand to make these different shapes. So this is great, but you know what? We can max it out even more. Maxing it out even more. Okay, that's about as much as I can take of that. So Michaela and I are on a quest to make the loudest sound we can. The first step is to make things louder without using electricity. We've looked at a resonance chamber, and now we're going to make a large megaphone. Sounds can be amplified by bouncing sound waves around in a space. When I put my phone into the glass acts as a resonance chamber. The sound waves bounce around inside the glass, and they combine and stack on top of each other. This makes the sound louder. Resonance chambers are used by musical instruments like an acoustic guitar. The wooden chamber bounces the sound waves around, and the sound waves build on each other to make the sound louder. A megaphone bounces sound waves as well. Instead of going off in all directions, a megaphone makes the sound waves all go in one direction. That's one of the reasons why a megaphone makes sounds louder, but only when it's pointed at you. So will a bigger megaphone work better? So we've made a larger megaphone, which is exactly the same thing. You just take a sheet and you roll it up, except our sheet was plexiglass covered in paper, and we've taped it together so it stays. And the idea here...
Oh yeah, bigger megaphone. We're gonna vibrate even more of the air inside of here, and hopefully this thing will be louder.
Okay, so you're ready to try it with the phone?
Yeah.
I think first we should try it with our voices, though.
Okay.
Now, what's your favorite season?
Awesome, I can totally hear you. That's amazing. And it would be fall. No, summer. Spring?
Think
It's
about it.
anything but winter. So the maxed out megaphone worked, but we still had to try it with my phone. Okay.
All right.
Yeah?
Oh yeah. Oh, definitely.
How about now?
No, not so much. Not so much. Oh yeah. Nope. Nope.
So that is a
That was
great
cool.
example of non-electrical amplification.
That's right.
Amplified the sounds, no electricity. Okay, bye-bye.
Please.
All right. Come on, make some noise! Well, how do you make noise? Well, to know that, you gotta know your sound. All sound is vibration. Here, take a closer look. You see? You got... Okay, let's try this again. All sound is vibration. The string of this guitar vibrates, which vibrates the air around it, causing the sound that you hear. Your vocal cords vibrate in your throat, causing you to make a sound. Ah, 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 la, 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 la. Look at this thing. Look at this thing. See how it's shaking back and forth? It's vibrating. Things that make a high sound, they vibrate faster. Vibrating really fast. Things that make a low sound, vibrate slowly. High note, vibrating fast. Fast! Fast vibrating! And now you know your sound. Everything has a resonance, a note that vibrates best at. Let's say this fish tank is, well, any container where sound would be vibrating, and the waves of water are actually waves of sound. Now, normally, sound waves will bounce around inside the container, off the walls, and go back and forth like that. And how fast I move this piece of wood is the frequency, or the note, that we're playing. I could vibrate this wood very fast and make a high note. I could move this plank very slow and make a low note. And the waves just bounce around inside the container. But there's a speed I can move this plank where the waves stop going side to side and suddenly get twice as big. The waves bouncing off the sides of the tank are meeting the waves going in the other direction. But what we end up seeing is peaks of the waves not moving side to side, just going up and down, like you see here. This is the resonant frequency of this container. So, let's max this out. Say I have a wine glass, and I wet my finger and I rub it around the rim. It vibrates at a certain note. That note is the resonant frequency of this wine glass. So what would happen if we were to play that note back to this wine glass really, really loud? And And yes, this is something you should not try at home. This note makes the glass vibrate the most. Finding the perfect note things vibrate best at is great for musical instruments, but it's not great for this wine glass. The sound waves are causing the glass to vibrate a lot. And because this glass is delicate, it can only vibrate so much before it breaks. The vibrations were so strong that the glass literally shook itself to pieces. Science! Sorry. Science! Oh, wait. Science! Michaela and I have tried a resonance chamber and a giant megaphone to make sound louder. Now it's time to move on to the next step of the plan, using electricity to help us amplify sound. And that means speakers! So, speakers that you have at home, 3 different speakers here, right?
Looks
3
really
different
busy.
cones.
Yeah, there's a lot going on.
So what's the deal?
Well, here at the bottom, we have a subwoofer.
Wait a minute, a subwoofer.
Subwoofer.
So it's a woofer, the word is woofer?
Yep.
And it's, okay, so it's for dogs. Right?
No, a subwoofer is for low notes here in our speaker.
Ah.
At the top here, we have a tweeter.
So it's for birds. It's birds, dogs. So let me guess, low notes?
Yeah.
Tweeters, high notes?
Yeah, high notes. And then we have this guy here in the middle, and that's called your mid-range speaker.
Oh, that's not nearly a cool name. Now we have speakers, we've taken a look at that, but why don't we take one apart,
Cool.
right?
Yeah,
Because
let's do it.
I've got this one here that I spilled juice on, so it doesn't work anymore. So I've kind of taken it apart. So
Cool.
it's got,
Man, that's awesome.
okay, so it's got the cover. That's cool. So what I find interesting is there's the speaker and the wires, right? Because it's electrical amplification. But check this out. This is just a ring to hold that on. And the rest is just an empty box.
We know what that is. Resonance
chamber. That's right. So that's why it's an empty box. So
Let's take this apart too, see what's going on.
So that's the paper cone, right? So that's that's the drum, I guess. It's like the eardrum, the thing that vibrates.
Yes, yeah, this whole thing vibrates.
So this whole thing.
That's for electromagnet. When we turn this on, the electromagnet goes on and off, and it's causing this whole thing to vibrate.
So that's how it works. It's the electricity turning the electromagnet on and off.
Exactly.
And it's on and off and on and off and on and off and on and off. And then it makes it vibrate at certain speeds, right? Hertz. The number of times it vibrates per second is hertz. What we could do is we could max it out with the speaker and plug the phone into speaker. But this step does not feel like Science Max to me because anybody can do that, right?
Yeah.
You can just turn up your television right now, and that's pretty much the same kind of thing. We need electrical amplification, but maxed out.
Max it up. What are you thinking?
Okay, so I've got a friend, and he's got a stereo system that he built, put together, and what he does is he tours different cities. So he said he'd bring it by Science Max headquarters.
He's gonna bring it here?
We gotta go outside.
See this thing.
And it's very loud, so we have to go outside.
When's he coming?
Right now. All right, let's go check it out. Seeing sound vibrations is fun. This kind of speaker is a special kind. It's called a subwoofer, which is designed to give you the low notes, the big rumbly bass sounds. I tilt the speaker so it's facing up and cover it with big sheets of plastic wrap, which I push into the cone. Then, tape it so it's nice and secure. Then, what you need is some cornstarch mud, which is 2 parts cornstarch, 1 part water. I've got some yellow cornstarch and some blue cornstarch. This experiment works the best with low notes. I'm playing a tone through the stereo that is very low. Here's what happens when I turn up the volume. It's alive! You see, cornstarch mud is a shear thickening fluid, which means when you impact it, it turns solid. So the vibrations from the speaker cone are making the cornstarch mud impact, and that's turning it into a solid. But then it sort of also melts back into a liquid, so you get little columns of cornstarch
coming up and falling down again. It's like it's dancing. Whoa! Visual sound waves. Science!
So Michaela and I are going to max out sound. To do that, we need a maxed out sound system. This is gonna be amazing. This
So
is gonna be super maxed out sound experiment. This is
so
James,
pumped.
Michaela.
Hey, James, how are you?
Thanks for coming, buddy.
Nice to meet you.
So, tell us about your speaker system. It looks a lot like a vehicle.
This is my audio van. It's got 4 15-inch subwoofers in the back. It's got a whole bunch of power to power it, and I'm glad to be here to let you guys hear it today.
Wow.
So if I have a speaker at home, like a little speaker like this, how many watts do you think that would be?
Somewhere between 15 and 25.
15 and 25 watts.
Yes.
And you've got 4,000.
Yes.
So that's a lot more.
Yeah, quite a bit.
And subwoofers, they play low notes.
Yes.
So is that better when you have a van like this?
With a car audio van like this, you want to play low notes. Like your house stereos and that will play anything from 120 to 200 hertz. I'm playing 20 hertz to about 35 max for you guys today.
So that's like a
Yeah.
sort of rumble of
Yes,
thunder,
very
kind
low.
of blah, 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 blah,
Yeah.
where you really feel it.
Yes.
Like a train going past almost.
Oh, that's cool.
So we get our hearing protection on and we try it out. I know what you're thinking. Phil, what's the point of having loud music if you can't really hear it? Because we've gone from listening to music to feeling it. The sound waves are so strong that they have become a physical presence. Michaela's hair flies around because the air from the speakers is creating shock waves. The sound waves are so powerful, they move the air back and forth, which makes Michaela's hair dance all over the place. And my hair, not so much. I'm totally jealous of your long hair.
Yeah, you need to get longer hair.
Okay, hold on, I'll go around.
Okay.
Whoa! Science back! Experiments at large! Super sound! High fives! Okay, ready to go again?
So cool. Yeah, let's do it.
Okay, here we go.